Hi, hello. Welcome to the second part of exploring magnets. In the last session, we discussed properties of magnet. First, we will revise them. Then, we'll move to the next topic. Once again, pole. What are the poles? The end of a magnet that has maximum force. That is attraction force, magnetic force. We call it as poles. Or otherwise, we can say it poles will have maximum magnetic strength. Poles exist in pairs. So what is the meaning of pairs? So we have two poles. One is north, one is south, right? So north pole and south pole. Magnetic poles cannot be isolated. So even if you divide the magnet into pieces, you cannot make it as isolated pole. So what is that? Already we explained it. So if magnet is having north pole and south pole, if we divide into two pieces, yes, it divides into three pieces, but every pole, every magnetic piece will have north pole and south pole. North pole, south pole. North pole, south pole. That is, magnetic poles cannot be isolated. Unlike poles attract, right? What are the unlike poles? North, north, south, south poles will attract. Like poles, unlike poles will attract, that is north, south, south, north will attract. Like poles, north, north, south, south, poles will repel. These are like poles, these are unlike poles. Test for magnet. How can we test the magnetic property of any substance? By a test called repulsion. It's a sure test for magnetism. The freely suspended magnet always comes to rest in the direction of north and south. So what is a freely suspended magnet? Take magnet and tie it with a thread, right? If I tie it with a thread and if I suspend this, we call it as a freely suspended bar magnet, right? This is the freely suspended bar magnet. Now it is moving. If it comes to rest, it will come to rest by showing the north and south direction of the earth. See here. So most probably after coming to rest, so this is the way it will come to rest. And now if you see it, see the dot we represents north and this is the south. So according to our geographical location, this is the north direction, this is here south direction. Why the magnet always shows north and south direction? Question. Earth is also having a magnetic property. We know that Earth is divided into three layers. The innermost layer is core. Outermost layer is crust. And between crust and core, we will have a mantle. Here, the innermost layer of the earth will have high temperature. So, whatever in the core, they are in a liquid form. So, what is the form in the core? Liquid form. Why? Because there is a high temperature. So, whatever the substance that fall into the core, it will have in a liquid state. That liquid state we call it as molten lava state, right? This molten lava will have a charge. So why? Because earth is moving. If Earth is moving, even this lava will be in a movement. This moving liquid will exhibit a ion charge. That gives the magnetic property to the Earth. So here, think if it is, this is the North Pole, geographical North Pole, and this is the geographical South Pole of the Earth. North Pole and South Pole. But it is geographical North Pole, geographical South Pole. The geographical North Pole is the South Magnetic Pole. South, or you can write magnetic South Pole. Geographical South Pole is magnetic North Pole, right? Yes, why geographical North Pole we treat as magnetic South Pole, geographical South Pole we treat as magnetic pole. See here, like poles, unlike poles. Unlike poles attract, like poles repel, right? If it is North Pole, obviously it will attract South Pole. That's why it is a magnetic South Pole. If it is South Pole, it will attract North Pole. That's why it is magnetic North Pole. So these are the properties of a magnet. Now we will move to the types of magnets based on their shape. So, based on our application, we have different types of magnets based on their shape. Right? Types of magnet. First, I'll write the shapes, then I'll show one by one. Types of magnets based on their shape. One is bar magnet. Bar magnet. Needle magnet. Hearts. Horseshoe magnet. Spear magnet. Ring magnet. Disc magnet. These are the types of magnets based on their shape. Bar magnet. This is the shape of a bar magnet. Rectangular shape. North and South Pole. Needle magnet. So the magnet will be in a form of North and South. Horseshoe magnet. This is your shape of your horseshoe magnet. One is north, another one is south. Spear magnet, like a ball. Ring magnet and disc magnet. This is the disc magnet. Obviously, all will have one north and south. Even the ring magnet, North Pole, South Pole. Here also will have north and south. Right? These are the types of magnet. Now I'll show one by one. Right? This is a bar magnet. If you see that, the dot represents North Pole and this one is South Pole. Bar magnet. Horseshoe magnet. So this is the horseshoe. Dot represents North Pole. This is your South. Needle magnet that we used in the compass navigation purpose. Can you see it? So this, whatever in the inside, this is called magnetic compass. If you see that in this, so that is called a needle magnet. So see, it will deflect. So based on that, it will deflect. See. Right? Now, spear magnet. See, this looks like the balls. Spear magnets. Ring magnets. Can you see this? Ring magnets. See, if I reverse them, see, they will not attract, they will repel because they are like poles. But here, right? But here, see, right? And disc magnets. These are disc magnets. Why we are having different shapes of magnets? Already I said before, these shapes are based on their application. Horseshoe, first one is bar magnet. So bar magnets are used in laboratories. Bar magnets are used in laboratories or in medical applications. So in medical applications and in laboratories, we use bar magnet. Right? Needle and magnet. Yes, previously I showed they are used in magnetic compasses for navigation. They are used in magnetic compass. So why we use this magnetic compass? For navigation purpose. What is the meaning of navigation? To detect the direction when they are moving. Next, horseshoe magnet. These horseshoe magnets are used in industries, engineering applications to lift the heavy loads. So if I want to lift heavy loads, yes, they'll use the horseshoe magnet. Even in the dump yards, if they want to segregate the metal pieces, yes, they'll use the horseshoe magnet. Spear magnets. Spear magnets are used in consumer electronic gadgets. Consumer electronic gadgets. So whatever we use electronic gadgets, yes, in that we will use the spear magnet. Ring magnets and disc magnets are used in the toys, model makings and etc. So toys, in model makings, and even this ring magnets we are used in the speakers, right? In speakers, the size may differ, shape is same. The ring magnet size differs based on the amplitude and frequency of the speakers, but the shape is ring magnet. And disc magnets are also used in toys, model makings, right? They want to make any model, so then they'll use the disc magnets. These are the types of magnets based on their shape. Alright? Next, we will move to the next topic, that is electromagnet. In the last class, already we discussed that magnets are, one is natural, other one is artificial. Natural magnets are the lodestone, which contains a magnetite, or neodymium, a rare earth material. Already in the last class we discussed. And the artificial magnets are made by man by passing electricity. Today we will discuss deeply what is electromagnetic and where we use them. Electromagnets. Right? How we prepare an electromagnet? Take any iron piece. So what is this piece? Iron. Even you can take iron needle also. Iron piece. And wind with a wire. So this is the what we call wire. One terminal and the second terminal. The two terminals of the wire are connected to a battery. Right? Connected to a battery. This is a symbol of battery. One will have a positive, other one will have negative. Now, if electric current is passed, so this iron piece will have a magnetic property. It will act like a magnet. So it will produce a field like this. What is this we call magnetic field? Any object in this region it get attracted, right? So what we are doing is we are inducing a magnetic property in a iron piece by passing electric current. See, so think, yes, it is a magnet, but if it is not magnet, if you take any iron piece, so think if it is a wire. So what you should do means the wire you should take this wire and wire. This is called wire winding. Wire winding turns. So you need to have a wire winding, right? Yes. In this wire you will have a two terminals. Yes, 1 and 2. Now you need to connect these two terminals to a battery. Now if you pass the electric current, this piece will act as a magnet. How this magnetic property became? Because of passing of electric current. Now these electromagnets may be of two types. One is a permanent magnet, other one is a temporary magnet. So we can prepare permanent magnets and other one is temporary magnets. So when I can prepare a permanent magnet and when I can prepare a here, can you see this iron piece? This iron piece we call it as core. What's it called? Core. And this we call electromagnet is also called as solenoid. What we call? A solenoid. And this is called iron piece we call core. In iron piece we have a hard iron and we have a soft iron. So if you want a permanent or temporary, that core judge that whether you are having a permanent magnetic property or a temporary magnet. Right? Now, what is permanent magnet? If I disconnect this wire from electric current, yes, this iron piece will lose its magnetic strength, magnetic property. Then that magnet we call it as temporary magnet. So first we will discuss temporary magnet. Now electric current is passing. It is behaving as a magnet. If I disconnect from the current, this will act as a temporary magnet. So what is this? After disconnecting electric current, right? this will lose magnetic properties. Magnetic properties. Right? But the permanent magnet, even though if you disconnect the electric current, it will exhibit some magnetic property. Those magnets we call it as permanent magnet. That means even after disconnecting electric current, yes, it retains its magnetic properties. Right? For preparing permanent magnet, this is one of the method. We have two more methods, but we are discussing based on the electromagnets. So both are prepared by electromagnet method, but still one acts as a permanent, other one will act as a temporary. What's the difference? The difference is the core which are used in the electromagnet. So we have two, soft iron, hard iron. If you use soft iron, if you use a soft iron material, so then it will act as a temporary magnet. If you use hard iron, it will act as a permanent magnet, right? That means if this iron piece is a hard iron piece, yes, even though if you stop electric current, it will retain its magnetic property. That's why we call it as permanent magnet. If this iron piece is a soft iron, yes, it will not retain its magnetic property after disconnecting of the electric current, right? Now, what is the advantage and disadvantage? Here, that permanent magnet will have less magnetic strength. Permanent magnets will have less magnetic strength. But the temporary magnets will have more magnetic strength when compared to permanent magnets. More magnetic strength, right? More magnetic strength. And if I want to change the north pole and south pole, in the permanent magnet, I cannot change north pole to south as south pole and south pole to as north pole. That we call changing of polarity. If I am able to change north pole as south pole as north pole, that we call changing of polarity. That can happen in temporary magnets, but it cannot happen in permanent magnets. That means I cannot change polarity. What is the meaning of polarity? North pole and south pole. But in temporary magnets, yes, we can change polarity. How can I change the polarity? By changing the current direction, right? Now in this case, the current is moving like this. Now it is south pole. Think it is a north pole. If I change the direction, think if I change the direction, right? So now it is moving down. And if it is now, even these poles will change. One will act as north and the other one south, and even these directions will change. Right? By changing the current direction, I can change the north pole as south pole and south pole as north, because it is a temporary magnet. And here we cannot increase the strength of the magnet because it is a permanent magnet. Whatever the magnet strength, we cannot alter it. But in temporary magnet, we can alter them. So we can alter by increasing the current flow. by increasing the number of turns, by decreasing the gap, right? So we cannot alter magnetic strength. That means whatever the magnetic strength it is having, you cannot change that. But in temporary magnets, we can alter. That means if I want to increase, I can increase the magnetic strength. If I want to reduce, yes, I can reduce the magnetic strength of a temporary magnet, right? This is your electromagnet. Based on electromagnets, we have two types, permanent and temporary. So only the difference is the core material which we are used, right? And what is the best example of electromagnet? In your school, you will have a bell, right? Electric bell. Yes, that is the best example for the electromagnet, right? So today you observe how the bell will go. Same in the electromagnet. So if the current is passed, magnetic property is induced and it will hit the gong. If it hit the gong, it will lose the connection. Again it will return back. Again the electric current is passed. Again it will get magnetic strength. Again it will. So this happens continuously. So this is a application of the electromagnet, right? Now that electric bell comes under the example of temporary magnet. That means if you pass electricity, then only it will have a magnetic property. If you are not passing any electricity, it will not have any magnetic property. Now, what are the examples of the permanent? Where we use the permanent magnets? Doorbells. Doorbell is also a temporary magnet. But the magnets which we are used in refrigerators, in your boxes, in this watch also, this is a magnet. It's a permanent magnet. And it does not depends on the electric current. Right? Examples of the permanent magnet is we use in the refrigerators. That is fridge, right? Refrigerators, fridge, watches, in your boxes, right? And temporary magnets, that is electric bell and even your doorbells. The doorbells is also an example of the electromagnet, that is temporary magnets, right? Now these are the permanent and temporary magnets. Now we will move to the uses of the magnets. Already we discussed here uses of the magnets. Is there any other uses where we can use this electromagnets and magnets? Yes. Have you heard that whenever you go to hospital, I think the old age people, your grannies, our grandfather, our grandmother, they'll do MRI scan, right? That MRI scan works on the principle of electromagnetic property, right? How the machine can get the image of your body by using the electromagnetic property. Yes, uses of magnets. Here we are discussing the uses, both permanent as well as temporary magnets. The first one, remember, try to recollect what is the first use of the magnet. See, what is this? Magnetic compass. Here whatever we are using is a needle compass, needle magnet. So this is the first use of the magnets. What is that? Magnetic compass. So magnets are used in magnetic compass. So for which purpose we are using magnetic compass? For navigation purpose. And uses of especially electromagnets. Uses of electromagnets. Already now we discuss what is the use of the electromagnets. MRI scans. In MRI scan, right? What is the meaning of MRI? Magnetic resonance imaging. What is that? Magnetic resonance imaging. This MRI scan is worked on the principle of electromagnets. So by passing electricity, they produce a magnetic strength, and based on that, they will image your body and they will detect the whatever the images in your body. Next, speakers, loudspeakers. So now it is Ganesh Chaturthi. So speakers are used here and there. Yes, in that speakers you are used the magnets. If it is a that depends. The size of the magnet will give the size of the speaker. If you are having a big speaker, yes, the magnetic size used is also big. If it is even in your Bluetooth devices, yes, it is also used a magnet, but it is in a small, right? Speakers and headphones. Headphones. We use the electromagnets. Next, we used magnets in electric bells, right? So already we discussed in your schools we'll have electric bells. Those bells will work based on the electromagnetic property. Electric bells, electric motors, doorbells. In doorbells we use the electromagnets. Even if we want to separate the mixture in the dump yards, we use the electromagnets for separating metals from mixture. They use the electromagnets. And have you seen the ATM cards, debit cards? You would have a strip. That strip is also a magnetic strip. So magnetic strip is used in ATM credit and debit cards. Why they will use this magnetic? To recover your data, to store your data. If you want to store your data and if the ATM want to read your data, yes, that information is stored on that magnetic strip. Even in the SIM card, yes, in the SIM card also we will have a magnetic strip. SIM cards. This SIM card will store your information. Even if the phone want to read it, it should read from that magnetic strip. This is another example of the uses of the electromagnets. Next, used in the toys. Even it is used in the what we call CDs, DVDs, right? That is also magnetic coating, right? By using that magnetic coating, we can store the data and we can read that data for further uses. Yes. Last is in CDs and DVDs, we will use the magnetic coatings, and even the magnets are used in toys, right? Toys, watches. So these are the uses of the electromagnets, right? Shall we move to the next topic? That is magnetic field. Now, when I draw the electromagnet, I showed the curved paths, right? I said it's a magnetic field. What is a magnetic field? The space. See, this is a magnet. bar magnet, north pole and south. If I sprinkle the iron pieces on the magnet and if I tap it, so if I tap it, all the particles will arrange in a particular pattern, right? This is the way they will arrange, right? This is the way arrange, right? Why they will arrange in a particular pattern? There is some force which is making them to arrange in a particular pattern. That is called magnetic fields, right? So force, magnetic force. So how long the magnetic force, for how much region it will act? Now if I take the magnet, see, this is the magnet and north pole, north pole. So obviously they'll repel, so that's why I'm taking south pole, north. I kept here. Whether it is attracting, I need to bring it. Now, if you place like this, yes, I am feeling that, yes, this one is pulling this one is pulling this. Now, yes, it's in. Now I can feel that force. Now, right? See, attract. See, from here, I can feel that force. But from here, yes, I can feel this. But here, I'm not feeling any force, right? That means there is a certain space around this magnet where I can experience that magnetic force. That space around the magnet where we can feel the magnetic force, we call it as magnetic field, right? What is that? Magnetic space around the magnet where magnetic strength or magnetic force is experienced is called magnetic field, right? See, I am having a magnet, right? This is a magnet. Now see, from here, so I can feel that force. From here, I cannot feel. See, in this boat, if I am bringing here, whether it is attracting, now it's pulling. I am feeling that, yes, it is pulling. Now, see, yes. So, whatever the magnet will have a certain space around the magnet where we can feel that magnetic force. That space around the magnet, we call it as magnetic force. That magnetic force will make the iron spring rings to arrange in a particular pattern, right? So now can you see this particular pattern? How they are curved, right? These lines, if I join these lines, yes, this is the lines around the magnet. These are the around the magnets where we can experience the magnetic, right? Magnetic force, right? These lines are actually imaginary lines. Can we see the any line? Imaginary lines. See this bar magnet? Have you observed these lines around this bar magnet? No. This is our imagination, right? Yes, this is our imagination. That means the imaginary lines around the magnet where we can feel the magnetic force, we call it as magnetic field lines. What are the magnetic field lines? The magnetic field is represented by an imaginary lines. Magnetic field is represented by a imaginary lines, right? These imaginary lines we call it as magnetic field lines, right? These imaginary lines we call it as magnetic field lines. So what these lines are we call? Magnetic field lines. So where there is a magnetic force. And how these magnetic field lines once observed? They are in a closed curves. So magnetic field lines MFL. What are the MFL? Magnetic field lines are closed curves. So how they are? They are in a closed curves. Right? Whether they intersect with each other? No. Magnetic field lines will not intersect with each other. Why they not intersect each other? Think. If these two magnetic field lines. So if you see that magnetic field lines are in a closed curve loop, at every point, if I draw a tangent, that represents the direction. That represents the north direction. See? North. So if it is south and if it is north direction. This is north. Right? Think that if the two loops are intersected at one point, this line will show the tangent, this line will show the tangent, right? That means think if it is showing the north direction. Obviously this also shows the north direction. Is it possible at one point having two north direction? Not possible. So it's not possible to have two north direction at one point. That's why magnetic field lines will not intersect with each other. And if you observe clearly, so the magnetic field lines are more close to each other at the ends of that is at poles, right? That means the crowd of the magnetic field lines will represent the magnetic strength of them. So more curved lines means more magnetic strength. More magnetic strength. If there are less curved lines means less magnetic strength. Right? More curved lines, less curved lines. And the direction of the magnetic field lines. It is very important that and the outer ring and in the internal of the magnet will have two opposite direction, right? Here always the magnetic field lines will emerge from north and it will enter in the south. That means at the outer space, outer of the magnet, the field lines are from north to south. How they will travel? The field lines are from north to south. But inside the magnetic field lines are south to north, opposite to the outer. Right? So inside the magnet, they are south to north, and outside the magnet, they are from north to south. Right? So that you need to remember. Inside the magnet, magnetic field lines are from south to north. Outside the magnet, magnetic field lines are from north to south. From north to south. So now you understand what is the magnetic field lines, right? So once we revise, the space around the magnet where magnetic force is experienced is called magnetic field. And the magnetic field is represented by imaginary lines called magnetic field lines. The magnetic field lines are closed curves, and they will not intersect with each other. Why? Because if they intersect, that point represents there is a two directions of the north. It is not practically possible. That's why they not intersect with each other. More curved lines means more magnetic strength. If it is less curved lines, less magnetic strength. Inside the magnet, the direction of the magnetic field lines is from south to north. But outside the magnet, the direction of magnetic field lines are from north to south. Right? Now, so this is a diagram for a magnetic field lines for a bar magnet. For electromagnet, so this is the piece, iron piece, and what you need to have a wire wind, right? This is the wire, and it will connect to a battery. Right? So what is the magnetic field lines here? Here also they are closed curves. Right? So what will be this? If the lines are emerging, so obviously it is north pole, and this is south pole. Outside the magnet, the magnetic field lines from north to south, Inside the magnet, the magnetic field lines are from south to north. This is the direction. Have you looked the similarity? Yes. The bar magnetic field lines and the electromagnetic field lines are similar. Only thing, it is a permanent magnet and electromagnet is a temporary magnet. So based on the core. Even if I use a hard magnet, yes, it also becomes a permanent magnet even if I remove the electric current passing through it. Right? And this electromagnet we also call as solenoid. What we call? Solenoid. Right? And the last topic is for today's session, magnetic flux. Magnetic flux. What is the magnetic flux? See here, this is a bar magnet. So these are the magnetic field lines. Right? North, south. If I take another bar magnet, Is there any difference between these two? Yes. These are having only 3 magnetic field lines and these are having 1, 2, 3, 4, 5, 6. Right? So magnetic field lines, magnetic flux means number of magnetic field lines that produced by a magnet. Number of magnetic field lines produced by a magnet, we call it as magnetic flux, right? That means, see, by observing these two figures, which is having more magnetic strength? Obviously the second one, because it is having more number of magnetic field lines, more space, that is, it is so powerful that it can attract the body the longer space. Here it is having less magnetic strength, that means only up to this region it will have a, you can feel the magnetic force, beyond that you cannot feel the magnetic force. Thank you for today. We will continue tomorrow the session, how we can take the methods, how we lost the demagnetization, how to prevent the demagnetization, how we need to protect the magnets, how we need to take care of the magnets, how we need to handle them. Okay, for today we are going now. Bye.